Today we're looking at exercise 10E, which is consequences of the factor theorem. So there's no new theory here, we're going straight into the examples. It says use the factor theorem to write down in factored form a monic cubic polynomial that has zeros at -2, 1, and 5. Monic, remember, means that the leading term of your polynomial has a coefficient of 1. So all that we need to do for that, if we have 3 zeros there and we know it's a cubic, my polynomial is simply going to be, for the x minus, the -2 there, it would become an x plus 2 in brackets. The positive 1 would become an x minus 1, and the plus 5 would become an x minus 5. And that is it. That's all we need to do. However, part B is a little bit more complicated, because again we have a cubic polynomial, but this time we have a leading coefficient of 8, so it's not monic anymore. We're still given the 3 zeros at -1/4, 1/2, and 3. So we can't simply go p of x equals, for the -1/4, go x plus 1/4, and for the 1/2, go x minus 1/2, and for the 3, go x minus 3. Because if I was to times out x times x times x, that just gives me a 1x cubed. And I know that my leading coefficient has to be an 8. Now, fortunately, see how I have a 4 and a 2 on the bottom of those two fractions there? 4 times 2 does make 8. So if I could find a way to rewrite these first two brackets here, so that they are at the front of my x's. So for the -1/4, I would do 4x plus 1 in that bracket, because I know that if I did 4x plus 1 equals 0, I would get 4x equals -1 and x is equal to -1/4. I'm just turning it back into that form to get the 4 in the front of my x. And the same thing with the 1/2. I would put the 2 at the front of the x, so that would be 2x, and it would need to be a -1, so that would become a +1 if you were to move it back across. Okay, now if you were just to do a little check, you go 4x times 2x is my 8x squared, times another x is 8x cubed. So it is a cubic polynomial that does have a leading coefficient of 8. Question 2. Use trial and error to find as many zeros of p of x as possible. Use long division to divide p of x by the product of these known factors, and hence express that polynomial there in factored form. So we did this last lesson, but this will be good for a quick little review. To completely factorize that, I need to find all my factors. So first of all, I look for possible factors. The possible factors come from this 12 here at the end. The possible factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, not 5 or 6, so just is 6, sorry, plus or minus 6, and plus or minus 12. So I need to start checking. I need to start subbing things into that equation to see which ones would work. So we usually start at 1 and we work our way up. So p of 1, when you type that into your calculator, 2 times 1 to the power of 4 minus 5 times 1 cubed minus 5 times 1 squared plus, you get the idea. That does equal 0. So straight away we have found that x minus 1 is a factor. Now I'm not going to do all the different testings here because we do have a limited amount of space on this page. -1 doesn't work, but +2 does work. So our second one is going to be x minus 2 is a factor. So once I have found 2 factors, then because it's a degree 4 polynomial, I'm hoping that I can find my other 2 by using long division. So the 2 that I have, the x minus 1 and the x minus 2, I times them together and expand them out. That's x squared minus 2x minus x plus 2, which is x squared minus 3x plus 2. And then I'm going to do my long division. So my polynomial was 2x to the power of 4 minus 5x cubed minus 5x squared plus 20x minus 12. And I'm dividing that by x squared minus 3x plus 2. Let's divide. 2x to the power of 4 divided by x squared is 2x squared. Timesing it back out makes 2x to the 4. 2 times 3 is minus 6x cubed. 2 times 2 makes 4x squared. Subtracting the first ones cancel. Minus 5 plus 6 would make a positive 1x cubed. 5 minus 4 is minus 9x squared, and bring down the next term. Dividing the next one. X cubed divided by x squared is an x. Timesing that out is x cubed minus 3x squared. X times 2 is plus 2x. Subtract. Minus 9 minus minus 3, so plus 3 is minus 6x squared. 20 minus 2 is 18x, and bring down the minus 12. Divide again. Minus 6x squared divided by x squared is minus 6. Timesing it out. Minus 6x squared. Minus 6 times minus 3 makes plus 18x. Minus 6 times 2 makes minus 12, which means they're all the same there, so that's a remainder of 0. So I have got my polynomial. The first two factors I have found were x minus 1, x minus 2, and I now have the 2x squared plus x minus 6. Now, to factorize that, I have a non-monic quadratic there. So I need to times the 2 with the minus 6, which is minus 12. I'm looking for two numbers that times to give minus 12, and add to give the 1 that's in the middle there. So that would be a plus 4 and a minus 3. So we need to split the middle term to be 2x squared. We're going to have a plus 4x and a minus 3x and minus 6. Then we need to factorize in pairs. So the first two terms I can take out a 2x, which would give me x plus 2. The second two terms I can bring out a minus 3, which would give me x plus 2. Then I bring my common factor of x plus 2 out the front, and 2x minus 3, the things from the front, go into the second bracket. So now that is factorized, I can finish my polynomial over here. X minus 1, x minus 2, x plus 2, and 2x minus 3. So that last bracket we would never have been able to get using our possible factor method up the top here by checking, because we don't check for halves or 1.5. Okay, so that's it for question 2. On the next page we have question 3. Write x cubed minus 2x squared plus 5 in that form there. So what we want to do is we want to equate the coefficients. So I'm going to write this down as one big equation where that is going to be equal to, we even talked about these questions before as being congruent. They're exactly the same in every way. And what I need to do is I need to expand out the right-hand side. So I've got ax cubed, leave the b out the front, expand that quadratic there. So that would be x times x is x squared, 3 times x is 3x, and double that, which would make 6x, and 3 times 3 is 9. Expanding the next bracket, I get cx plus 3c and a plus d on the end. I still need to expand that second bracket there out again. So ax cubed plus bx squared plus 6bx plus 9b plus cx plus 3c plus d. Then I can start equating my coefficients, which means I start with the highest power of x, which is the x cubed terms. On the left-hand side, my x cubed has a coefficient of 1. On the right-hand side, my only x cubed term is the first one here, which has a coefficient of a. So a equals 1 is my first pronumeral found. Then I go to my x squareds. On the left-hand side, my x squared has a coefficient of -2. On the right-hand side, I have an x squared, which is just 1 there, which is the b. So b is equal to -2. Then I want to check the x to the power of 1 terms. So on the left-hand side, there is no x term, which means the coefficient is 0. On the right-hand side, I've got a 6b, and I've also got a plus c down here. Now I know that b is equal to -2, so I can sub that in. 6 times -2 plus c. 6 times -2 is -12, which means that c is equal to a plus 12. And I then want to find my constant, which we call x to the power of 0. On the left-hand side, my constant is a 5. On the right-hand side, I've got 9b, I've got 3c, and I've got d. So subbing in the b and the c that I already know, I would get 5 equals 9 times -2 plus 3 times 12 plus d. 9 times -2 is -18. 3 times 12 is 36 plus d. And if I move the -18 and the plus 36, if I move those across to the other side, I get d is equal to 5 plus 18 minus 36, which is 13. So now that I found a, b, c, and d, the goal was to write x cubed minus 2x squared plus 5 in that form there with the a, b, and c and d subbed in. So that would be a is 1, so it'll be x cubed plus b, which is minus, so I should change that to a minus 2x plus 3 squared plus c, which is 12x plus 3, and then plus d, which is 13. Geometric implications of the factor theorem. The graph of a polynomial function of degree n is completely determined by any n plus 1 points on the curve. So that is talking about the number of, you'd have n intercepts plus obviously your y-intercept as well. Number 2, the graphs of two distinct polynomial functions cannot intersect in more points in the maximum of the 2 degrees. Okay, so a parabola, for example, a degree 2 polynomial, and a line can only intersect at most at 2 points because that's the highest degree of the quadratic there that I've given you as an example. So it works for higher powers as well. Number 3, a line cannot intersect a graph of a polynomial of degree n in more than n points. So it's not possible for that line to cut that parabola in 3 places because it was only a degree 2 polynomial. All right, so example number 3. By factoring the difference, which is f of x equals p of x minus q of x, describe the intersection between the curve p of x and q of x and find where p of x is above q of x. Sounds a little bit complicated, but it does give me steps on how to get started. It says by factoring the difference. So I need to find out what this f of x is. and it's p of x minus q of x. So p of x, I'm told, is x to the power of 4 plus x cubed plus 10x minus 4. And I want to subtract the q of x. Now I'm going to expand the minus through. That's minus x to the power of 4 minus 7x squared, become a plus 6x and a minus 8. So x to the power of 4 minus x to the power of 4, they cancel out. But I've got x cubed, and I've got 10 x squareds I should do next. There's a minus 7x squared. Then the x's, I've got 10 plus 6 makes 16x, and minus 4 minus 8 makes minus 12 for the constant. So it says to factor the difference, which means I want to factorize that. So I need to find a 0. So you're looking at this 12 here. So you've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. And you need to sit there and check and check and check until you find 1, because we can't factorize a cubic without finding at least one of the factors first. And the factor that I found first when doing that was f of 2. Subbing in f of 2, I get 0, which means that x minus 2 is a factor. Okay, so then I do long division. I've got my polynomial, which was x cubed minus 7x squared plus 16x minus 12, and I'm going to divide that by x minus 2. So that is x cubed divided by x is x squared, times that back out, x squared times x is x cubed. X squared times minus 2 is minus 2x squared, and x, then I need to subtract. The first ones cancel. Minus 7 plus 2 would make minus 5x squared, and bring the 16x down. Minus 5x squared divided by x is minus 5x, and times it back out. Minus 5x times minus 2 makes plus 10x. Subtract. First ones cancel. 16 take away 10 is 6x. Bring down the minus 12. 6x divided by x is a plus 6. Timesing it out, I get 6x minus 12. So I finally get, I'm going to draw it over here. My f of x is equal to the x minus 2, the factor that I found, and the x squared minus 5x plus 6. The quadratic I can factorize further, timesing to give minus 6, plus 6, and adding to give minus 5 would be x minus 2, x minus 3. And that is actually x minus 2 all squared times an x minus 3. So I've completely factorized that, the f of x that I was asked to find there. Now what that means for my two curves, the factorized version there tell me where the two curves intersect. So my curves intersect, so therefore p of x and q of x are going to intersect at 2 and 3. But the degree of the root there also tells you something as well. If the x minus 3, if it's only a power of 1, a normal standard root, then they cross. The two curves are going to cross at that point. However, if I have a power of 2 on there, like I do for that x minus 2, that means that those two curves are going to bounce off each other at that point, or in other words, they are tangent at that point. So let's finish this little statement here. P of x and q of x are tangent at x equals to 2 and cross at x equals 3. Okay, and that is it.